Hi, my name is Alexander Smolin, and this is our Milestone 5 E102 projects. So on this first slide here, we have our overall poster, and in the middle, we have this really great diagram on providing safe water into these low-income communities. And then all around it are individual slides that we will all get into. So our next slide here, the target audience slash population. Our target audience for providing clean water to is all low income and disadvantaged communities that lack access to clean water due to pollution and or a lack of infrastructure. And these communities are often referred to as slums, and they really are just worldwide. And but two examples of these would be Mumbai in India and Lagos in Nigeria. And we also have a good picture here of a woman sitting outside of a slum in Bangladesh. And then on our next slide, we have our challenge statement. Our solution addresses the lack of clean water for communities in low income and disadvantaged areas. Access to clean water in these communities will benefit the target population with a reduced mortality rate and an increase in quality of life. Clean water will prevent waterborne diseases such as cholera and will reduce the mortality rate greatly for children and the elderly. Making clean water readily available in these communities will also enable the population to have more time for work or education, as they no longer have to take time to search for clean water. And then we also have another good picture here of two children gathering water from a well. And I'm going to hand it off to my teammate.
Hi, my name is Blake, and I'll be presenting our main visual, existing technology, marketing plan, and design shortcomings for our Milestone 5. Our main visual shows the water network in a low income community. On the left, untreated water from a local source flows into the communal purifier. Inside that unit, filters and disinfection remove contaminants. And then from there, we have clean water traveling through repaired pipes into homes. And along those pipes, we have like low cost sensors monitoring like the water quality. And then at the bottom, you can see a training area where residents can learn how to operate and maintain the system themselves within the community. So this design uses existing technology, like standard like metal pipes and like purifying units and like basic electronic sensors, as mentioned. So because we're upgrading and repairing what already exists, the system is more affordable and is easier to implement in many different communities. So to encourage people to actually use this system, our marketing plan focuses on grassroots education. We would hold community workshops, demonstrate like how the purifier works exactly, and explain the health risk of the contaminated water compared to the benefits of consistently clean water for the families. This way, to like ensure that there's an actual drive to keep the water clean and not just letting it become contaminated. So finally, there are some important design shortcomings, such as like if training is done poorly, the system can be mismanaged, and the water can become unsafe again. Also, sanitation around the pipes and treatment areas, if they aren't controlled, then contaminants can leak back into the supply. So these risks show why like ongoing training, monitoring, and maintenance itself would be like critical parts of our solution and not just the hardware itself.
Hi, my name is George, and I'll be going over the solution brief, the relation to engineering grand challenge, the feasibility study, and the next steps. Starting off with the solution brief, our proposed solution is a program such as a Safe Water Initiative. This provides safe and up-to-date water sources for low-income communities. It combines the purification of water and the infrastructure used to supply the clean water. The key component of these solutions are as follows. The communal water purifier units. These will be affordable water filtration units that provide safe drinking water. The pipe repair and infrastructural upgrades. There will be upgrades to repair any outdated equipment to ensure the quality of technology purifying and supplying the water is in excellent condition reaching homes. The possibility of leaking water becoming contaminated would be eliminated. The community purification training provides training on safe usage of the water supply, education on maintaining filters and necessary hygienic practices for clean water. This will ultimately allow for a maintained water supply, securing the money spent on this program to be wasted for many years. observance of the quality of water, cost-effective monitoring by use of the sensors to check for contamination of water sources. In this, the detection of any issues early on will be fixed quickly to keep the water supply program running. The community can use the training of water purification to oversee the water quality themselves. For our next steps, we would begin the fundraising process so we could begin to recruit engineering firms and architects to start the development of the water supply network, as well as beginning to find skilled laborers who would like to join the process of installation once the development phase has been completed. Moving on to the feasibility study of our design, we found that although the technology exists to provide clean drinking water to communities, it will not be cheap to build and repair the infrastructure, with a cost of development estimated at around 12 million United States dollars, which would likely grow higher because of the large labor cost for skilled workers to travel to remote areas to build the infrastructure. Logistical issues like the training of water supply network workers and keeping water uncontaminated throughout storms and natural disasters will also add a layer of difficulty to providing a long-term solution for clean water in disadvantaged communities. Our solution could be adapted and used throughout communities in different parts of the world to ensure clean water for all. Next up is the relation to the engineering grand challenge. Our design provides clean water to low-income disadvantaged communities without it. This falls under the grand challenge of providing access to clean water, as our solution aims to provide clean water for the aforementioned communities that lack access.